Welcome to our discussion of interpretations and models. We've already discussed interpretations and what it means to give an interpretation, for example, by specifying the universe of discourse, the extensions of all the predicates, and the reference of the constants. Now, there are times when we might be interested in finding an interpretation on which a given sentence is true. So, for instance, suppose we consider the following sentence. For all x, f of x, and if there is an x, g of x, then for all x, f of x, then g of x. And suppose that that is our sentence that we're interested in, and we're interested in finding out whether there's an interpretation on which this sentence is true. Now, the way to proceed here is, of course, by now very familiar. We simply do the truth tree for this sentence, and if the tree does not close, then there exists an interpretation on which the sentence is true. Let's just do that and see how this works out. This tree begins with decomposing the conjunction. So we have for all x, f of x, that comes from 1 by conjunction decomposition. And then if there is an x, g of x, then for all x, if fx, then gx. And that's again from 1 by conjunction decomposition. And now we have no choice but to branch. So because the main logical operator in the sentence on line 3 is the horseshoe, so we branch it like that. We have the negation of the antecedent. It's not the case that there is an x, g of x. And over here we have for all x, f of x, then g of x. And that comes from line 3 by conditional decomposition. And on line 5, we're not quite done with this branch, or the other branch for that matter, but this branch, we have to decompose that. So this is for all x. It's not the case that g of x. And that comes from 4 by negated existential decomposition. We're not free to say that we have a completed open branch here until we instantiate all the universal quantifiers here. So we have to do FA, which comes from line 2 by universal quantifier decomposition, and we also have to do not GA. And I can use the A again because this is a universally quantified sentence and not an existentially quantified sentence. Okay, that gives me a completed open branch here. And then just for the sake of completeness here, that is to say, just to see how it all pans out, let's do the other branch as well, because on this branch I have two universal quantifiers, so I need to do FA from line 2 by universal quantifier decomposition. By the way, line 7 came from 5, of course, by universal quantifier decomposition. Okay, so back to this one. FA came from line 2 by universal quantifier decomposition. And then I want also now to do a line 9, which is going to be FA horseshoe GA. And again, I can use A again because these are all universal quantifiers. That comes from 4 by universal quantifier decomposition. And this branch is, again, not FA on one side and GA on the other. So we actually have two completed open branches. We can use either one to create an interpretation on which the given sentence at the top is true. So for instance, if we use the branch on the right-hand side here, we can see that our interpretation is going to require only one element in the universe of discourse, and the predicate f of x is going to have that element in its extension, and so is the predicate g of x, and A is just going to be that one. So now this is an interpretation, this specification of the extensions of the predicates, the universe of discourse, and the reference of the constants. This is an interpretation on which the original sentence is true. Now, it is customary to call this a model. So in other words, a model is just an interpretation on which a sentence, or more generally speaking, a set of sentences, is true. So let's now just write down that definition so that we have it in case we need to use it later. Because the definition is, as I pointed out, not something that applies only to one sentence, but in general, we can define a model in the following way. We can say that a model for a set of sentences gamma is an interpretation on which each member of gamma is true. And that is just what we mean by a model. And this concept of a model is a concept that is used in a variety of different areas of philosophy, though mostly in philosophy of science and perhaps in philosophy of language. It's also the same concept of a model that's used in mathematics. For us, it is therefore interesting to know exactly what is meant when someone talks about a model of a theory. And quite simply, if we just think of a theory as a set of sentences, then the model is just an interpretation on which all of those sentences are true. And it's just that simple. Now, when we talk about an isolated sentence, or if you want to be more precise, a set that contains only one member, it is also fairly common to talk about a counter model. A counter model is an interpretation on which at least one member of the given set is false. Now, in the case where we are looking at a set that has only one sentence, the counter model, or the existence of a counter model, basically tells us that that sentence is not a tautology, because there exists at least one interpretation on which it is false. In practice, the way to search for a model and a counter model when we're looking at just one sentence or a set with just one member in it is as follows. To look for a model of the set gamma where the set gamma just contains one sentence, to find a model, we simply begin a tree with the sentence P as our set member. To find a counter model, for that same set, what we have to do is look for a model for a different set, which is the set containing the negation of P. Because if there's a model for gamma prime, then there exists an interpretation on which not P is true, which is the same thing as saying that there's an interpretation on which P is false. So, to find a counter model for this set gamma up here, what we would do is start a truth tree with the negation of the sentence. And if this tree does not close, then there will exist an interpretation on which tilde P is true, and hence there will exist an interpretation on which the original sentence is false. So, to say it differently, when a sentence has a counter model, it is not a tautology. Or, to say it differently yet again, a sentence is a tautology if and only if it does not have a counter model. Now, the notion of a counter model for sets of sentences in general that have more than one member is maybe not that interesting to us. But what is much more interesting is whether there is an interpretation on which the premises of an argument are true and the conclusion is false. If we think of a standard sort of situation where we have an argument with a variety of premises and then a conclusion, what we want to know is not whether the set that contains P1 through Pn and C has a model. Instead, what we want to know is the following. Does the set P1, P2, all the way to Pn and the negation of C have a model? Now, if this peculiar set with the premises and the negation of the conclusion has a model, that means there exists an interpretation on which each member of the set is true. That means all the premises are true and the negation of the conclusion is true. In other words, the conclusion is false. So in other words, if it has a model, then the argument is invalid. If it doesn't have a model, that peculiar set, then the argument is valid. So sometimes the concept of a model can be a handy one to use, not only when we talk about tautologies, but also when we talk about validity of arguments.